All right. Hi, everyone. Welcome to IoT Show Deep Dive. We are really excited to have you here. I'm also equally excited to have Eric here. He is the head of Azure IoT Industrial IoT.
Very good.
And he's going to be here talking about Industrial IoT. So I'm excited. Eric, do you want to talk a little bit more about your position?
Sure. So we started the Industrial IoT team in Azure 5 years ago. And we've been building up a team both in Redmond and in Munich. Certainly in Germany, there's a lot of industrial automation going on, so it made sense to set up the team distributed. Yeah. And I've been leading it from the engineering side, together with my partner in crime, Christoph Berlin. Mm-hmm. And we've been working on a platform based on Azure IoT that is specifically geared towards industrial automation, industrial IoT, working with manufacturers, machine builders, automation companies, and helping them achieve their digital transformation.
As I mentioned before, I'm excited. And one of the reasons why I'm excited is because this is one of the top requested deep dives that we've had, is actually for us to deep dive into offerings for industrial IoT, but what is our strategy, some best practices and some patterns, and then also show some demos as well. So with that said, if this is your first time coming to a deep dive, what it is one of our live events where we answer your questions in the chat room. So if you have a question, feel free to add it to the chat. We'll get to you during the event. And if you're watching this on demand, don't worry, you can still talk to us on the tech communities, which we'll show towards the end of the event. All right, so just to kind of give not to date myself, but over a decade ago, I was working in production line, and it was notorious for always going down. And this is the time before devices were actually connected to the cloud. A lot of the devices were a lot of the machines were pick and place, all the way from soldering waves, all that fun stuff. And I always remember when any of the machines go down, I would be the one that would have to fix it, but the rest of the assembly line would just stand around because there was nothing that they could do at that point once one machine in the line goes down. And not only was it one assembly line, it was multiple assembly lines. So you can imagine if I'm working on one machine that's down, and if other machine goes down on the other assembly line, you have one of those workers walking around trying to find another maintenance person to actually, make sure the assembly line starts up again. And so this is why I'm very passionate about this, because the improvements on the factory floor have been so huge over the years. And I'm excited for us to talk about those improvements, and hopefully no one will have to twiddle their thumbs like I did a lot over a decade ago with these connected factories.
Right, yeah, so certainly we see a lot of demand for this product, especially the manufacturers who obviously want to produce as efficiently as possible, are very interested in both detecting failures, but then also being able to run some simulation in the cloud using machine learning to predict failures and then try to avoid them in the first place.
Yeah, and then if it does happen, actually being able to send alerts and getting the right people to fix it as fast as possible.
As fast as possible, exactly.
Well, I won't hold this up anymore. I'll let you start giving the overview, and then after the overview and strategy, you'll deep dive into the demos.
Excellent, yeah.
Okay, perfect.
So with that, we're going to do a quick introduction, just an overview of what we're doing and why we're doing it, and then we'll do a little demo of our solution accelerator called Connected Factory.
That's great.
So really, what people realize is digital transformation in the industrial space is quite complicated, right? Yes. And people need good partners like Microsoft to achieve this in a step-by-step fashion. Yes. A lot of people jump in and want to do predictive maintenance, say, right? But obviously there's a process to getting there, and we have the tools to make it as simple as possible to connect machines, then start collecting data from those machines, then analyzing that data both on the edge and in the cloud, and then finally making predictions regarding possible failures, and and also getting field technicians quickly to, like you said, when your pick and place machine goes down, getting the right people there quickly to, fix the problem is essential, right?
Exactly. You don't want someone going on break and you didn't know you want to be able to alert them wherever they're at so they can go fix a machine.
Right. Exactly. Yeah. So what we've done is this is actually borrowed from Kagermann, who's kind of the godfather of platform industry 4.0 in Germany. And he created this 7-step process or 7-step model to doing digital transformation. And, obviously, like I said, back in the 70s when PLCs came out, they started using them to control machines, but they obviously have a digital interface, right? Which makes it attractive for doing industrial IoT because you have that digital interface to interact with, right? Exactly. And then, you need connectivity. You really don't want to connect your machines directly to the cloud, but you want to, connect them securely using things like our IoT Edge gateways.
Yeah.
And then you can start collecting data and building telemetry dashboards. And for the first time, those can be global dashboards where we can really compare production lines distributed around the world to one another and see why is one more efficient than the other, right?
Exactly.
And then once you have that telemetry, right, and you've been collecting it for a while, you might be able to see some trends, some patterns, but you're still human eyeballing the data at that stage, right? So you're not really using machine learning, but you have an expert looking at the data on a dashboard sitting somewhere in the world and being able to see, okay, there's a trend here, maybe this machine has a problem. And like you said before, it only takes one machine to stop an entire production line, right?
Exactly.
So you want to be able to identify those problematic machines in a production line as quickly as possible. So then you start collecting data from lots of different machines coming from lots of different vendors, right? I mean, usually a production line is like 30 years old.
Oh,
It's been retrofitted 20 times and, it's just...
So many different protocols, so many different, types of machines.
Right. Yeah. It's not let's say, a simple task to really be able to get everything to a common data model, right? But you need a common data model to be able to compare the data in the first place.
Exactly.
Right? So you need to start doing some data modeling and you need to start normalizing the data in the telemetry stream, right? From the machine to the edge to the cloud as early as possible. And what we decided is the people that know the telemetry best, because they probably were involved in setting up the machine in the first place, are actually on the factory floor. So we want to really standardize the data, normalize the data on the edge in the factory before it gets sent to the cloud. So by the time it arrives in the cloud, it's nicely formatted, nicely, uniform, using the same semantic model and all of those things. So the data modeling really is happening at the edge, right? And then once you have that, let's say, hierarchical data model, you can then start running machine learning and stream analytics on it automatically and start looking for issues by a computer rather than a human having to eyeball the data all the time.
Exactly. Right? And you can have the machine learning either live on the edge side or on the cloud side.
Exactly.
Or both. Yeah.
Exactly. So in some scenarios, for example, in an oil rig, right, where connectivity to the internet is super expensive, you want to do as much as possible on-prem. So it makes sense to do that, machine learning model possibly in the cloud and then download it to the edge and run it there.
Exactly.
Right? Yes. Exactly. And then finally, once you have those automatic insights, you can again get a human to make a decision what to do with it. Or even better, you can make a machine do that decision for you and create that self-healing system that everybody likes to have, right?
It's the dream. Yeah.
That's the dream, right? We're a little bit away from that in most scenarios, but we're getting there. And there are some examples where they've started to get these digital feedback loop going and making some simple decisions by machines rather than waiting for a human to say, oh yeah, there's an alarm here, I better do this or that, the other thing. Yeah. For example, when certainly safety critical things are always done locally, right? So if somebody's about to get hurt, you press the red button and that's it, right?
Yeah.
But for less critical issues, for example, a machine might be running hot, right? You might want to predict, well, is the machine going to take damage at that temperature or not? And if the machine builder has built a machine learning model and say, no, it's all good, you can keep going, then nothing has to happen, or you throttle it or something. And that could be something, for example, where that digital feedback loop comes in really handy, right? Yeah. And then really, once you have all that, you can start making predictions or making decisions based on predictions that guarantee that your production line will never go down. Or you create a product and that product will always be at a certain quality. And once you're there, you can start offering this as a service, right? Because then you have that guarantee. You can create a service, and this is what people like to be called, the pay-as-you-go model with outcome-based products, or between you and me, it's machines that never break, right? Yeah. And that's basically what everybody wants to achieve, but there's a process to it, and that's why we're kind of saying, let's do it step by step. Start with connectivity, then the telemetry, then the insights, then the analytics, and then finally the machine learning.
Exactly. You do have to go through that process, because if you don't get that connectivity first, then you can't continue on.
Right.
Yeah.
And quite often the connectivity is the hardest part. Yeah. Because the other parts are usually cloud enabled and cloud driven, and we have great tools and great dashboards for it. But the connectivity, really, with the vast majority of diverse systems in production lines, it's non-trivial to connect them, right?
Oh yeah.
But I'll talk about that.
Especially on a factory floor.
Yes, exactly. Yeah. But we have, I think, a good strategy there. Obviously, Microsoft is a great, ecosystem company and partner-enabled company. So we have a lot of connectivity partners that we work together with, and to really get the best-in-class connectivity solution for Azure.
Sounds great.
Okay. So what's vendor lock-in? So a lot of companies that we talk to, especially the manufacturers, are used to these large ecosystems that were built over years, and they're usually based on proprietary technology, and they've been forced to buy into this ecosystem, and once they're in, it's hard to get back out.
Yeah, so, service agreements too, and everything. Yeah,
exactly. And once you start buying hardware from a certain vendor, chances are it's not going to be super compatible to the next vendor, so it's more difficult to really get the best product, and manufacturers have clearly told us they will not accept a vendor locked-in product, right? So we've decided a long time ago to have a set of business principles and a set of technology principles for our industrial IoT offering that prevents vendor lock-in as much as possible.
That's great. Especially a lot of companies popping up. You don't know how long those companies will last, but there's many reasons why people are a little shaky on vendor lock-in sometimes.
Yeah, and 30 years support. Once you put something on a production line, you really need to support it for 30 years, or up to 30 years. So that you really want to have the right mechanisms in place to allow that to happen, right? So a long time ago, we decided, well, obviously, we want an open platform. We're using our Azure PaaS components, of course. We're building an abstraction layer on top using open standards, well-established industry standards, such that people can have that layer of abstraction and only use the open industry standard for interacting with the platform. We've built that partner ecosystem of connectivity providers, of gateway hardware vendors, to make sure that people have choice, right? And of course, we're partnering also with the OT companies to offer their products, like the automation companies, Siemens, Rockwell, Schneider, Mitsubishi, et cetera, to build their products and their cloud-enabled products on Azure too, right?
Yeah. It makes it easier, especially when you have multiple different machines. Maybe some of the machines have different vendors or different types of gateways or PLCs. So it's great that we have support across those different ecosystems.
Exactly. And it also fosters interoperability, right? So you want to give people as much choice as possible, and stuff should just work together, right?
Yes, ideally.
so then, of course, we also have a set of technology principles, and we've embraced open source from the start. Everything we do in the industrial IoT space is open source. It's all on GitHub. It doesn't mean that we just throw it out there, but we develop it in the open. But we're responsible for the quality. There are products just like any other Microsoft product. So we have regular releases, we fix bugs, but we also accept contributions from the community. Ideally, I found a bug and here's the fix, or, I found a bug is good enough, right? Yeah. So, fundamentally, we want to encourage participation. And that's one of the reasons why we also set up the open manufacturing platform, where we're really building an ecosystem of manufacturers, but also, suppliers, automation companies, and so on, to solve common problems in an open way such that everybody can benefit and not everybody has to fix or find a solution to the same problem.
Yeah, and I love that you mentioned we're also maintainers as well, because
Right.
you do see that with open source projects. I'm a huge open source advocate, and sometimes you see projects kind of go to the wayside because they don't have strong maintainers to help
Right.
out and contributors from the community.
Exactly. And then finally, of course, I mentioned it before, we want to use open data models as much as possible,
Yeah.
because fundamentally when you're modeling a machine that's been around for 20 years, chances are the information model built into the machine is not open, but you can convert it into an open data model such that you can do that analytics and compare the data from that machine to other data you may already have, right?
Yeah.
So final point, can make changes to the machines, right? I hear that all the time. They say,
yeah.
Eric, connect my production line to the cloud, but for God's sake, don't make any changes,
No,
right?
no, there's. I
So-
hear that all the time when
Right.
I'm coding with partners and customers. The same
Totally.
thing. We can't actually touch this, but how
Right.
can we get it connected?
Exactly.
Yeah.
So it has to be non-intrusive, right?
Exactly.
So we say, okay, can we add a gateway, right? Yeah, okay, gateway, fine. You can add a
Yeah.
gateway. So we say, okay, then the connectivity will be in a secure way through the gateway. Don't connect your machine directly to the cloud. Don't do that. Go through a gateway. Use a hierarchical network segregation. With ISO 95 compatible network layout, and then you're good to go, right? So that's basically what we've decided to do in a nutshell. I have this little diagram here where it summarizes our strategy. So we use open source, we use an open platform, Azure. We use open standards, and of course we use open data models. Specifically, what we're gravitating towards is the common data model, which is part of the initiative together with Adobe and SAP. So CDM is now supported in Azure Data Lake Gen
right,
2,
yeah.
right? So
Yeah.
we're using that, and that gives us that common store in the cloud for data models coming right off the machines. So in total, and in summary, obviously there's a layer to the platform. At the bottom we have the infrastructure layer. Then on top of that we have the PaaS layer that I talked about already. So things like Azure IoT Hub, Azure Data Lake, time series insights, all of these things, Stream Analytics would fit into that layer. Then on top we have our Industrial IoT layer based on standards like OPC UA and CDM. Then, of course, should you choose to use it, we have an app platform layer, IoT Central.
Yep.
And then finally, that's where it stops, right? We don't claim to be manufacturing experts, although we do have our own production lines too for things like Surface, right? So
Yeah.
we do have our own production lines, and we use our platform in those production lines. But for the general partnership, the idea of partnering with the manufacturers, for specific use cases and specific business problems, the partner or a contractor would actually build things like an OEE dashboard or a predictive maintenance application for a machine builder or so. Right,
Yeah.
that will always come from the partner, not from us.
And it makes
right?
sense. They know their industry the best.
The best.
Yeah, exactly.
And that's why I say winning together, because really it's a win-win. Everybody can concentrate on the bits that they know best, right?
Yeah.
And you create product together, right? So one of the things that we standardized a long time ago is OPC UA. It's really in Europe. It's
Everywhere.
It's everywhere, really
Really is.
everywhere, and also in Asia. In the US, we still have some work to do to increase awareness, but it's slowly getting better. And the reason for standardizing on OPC UA is again for the interoperability, for the common data model, and for security reasons, right? Because a lot of the older proprietary protocols used in machines don't have security built in. OPC UA, in my opinion, has the best security that I've certainly come across. So we use it as a kind of a firewall between the machine and the internet.
I'm curious on you'll be speaking a lot about OPC UA. How's that tie in with the work that we're doing with Azure IoT Plug and Play?
Right.
And the open modeling language. So for those who are not aware, we did release Azure IoT Plug and Play. It's an open language modeling language to make it easy to connect devices to the cloud, and with very little code or no code for the solution developer. So I'm very interested in how you see that mapping to industrial IoT, and what's the strategy there?
Right. So we've decided a long time ago for industrial scenarios we use OPC UA.
Okay.
Plug and Play has its right in other verticals, for example, healthcare and consumer products and so on. It's mainly used for modeling specific end customer devices, and for OPC UA or for industrial scenarios, OPC UA is kind of the common language and a common standard. And that's why we decided for industrial scenarios, we continue to use OPC UA. For other scenarios where there is no open standard or established industry standard, Plug and Play fits really well and really accelerates data modeling for a lot of folks because, like you say, very little code, right? Very little
it's great for the solution
effort.
developer. Yeah,
exactly. For the solution developer, it's great, and they can get going with the data modeling quickly. Like I say, in our case, there is already a data model in most machines.
Yeah.
And you basically just translate to OPC UA in a predefined format. I mean, a lot of the companion specifications already do the mapping automatically, right? So OPC UA has this concept of companion specifications where you map from things like MT Connect or BACnet or lots of different protocols, and you can easily bring existing data models to that common format. And we're also going to do a mapping in the cloud for things that require plug and play, right? So we can map from OPC UA to plug and play.
That's good. So you have that. At least you have that option.
Exactly. Yeah. So it's really a question of what do we need to do to enable certain features or certain services, and we're doing that mapping so the customer doesn't have to.
Perfect.
Right. So obviously, when we looked at data modeling for industrial machinery, we needed to solve certain problems, right? So we said, okay, well, we need a telemetry stream, right? So we need to pick up the data from the machine, convert it to OPC UA, and then send it to the cloud. Well, the OPC Publisher does that, right? That's exactly what it's for. It's on GitHub, like everything else, so there's a link. And really, what we've done is we worked with the OPC Foundation to extend the spec to cover cloud scenarios, right? So they decided to work with us on this extension to the specification. It's been released a year and a half ago, and it's called Publish Subscribe or PubSub. So the idea is that we pick up the data in the old OPC UA client server model, we convert it to PubSub format, which is just JSON encoding. UA binary, which is the kind of compressed binary format, is also supported, and then we send it to the cloud using things like MQTT or AMQP. So that's basically what the publisher does. It's our telemetry plugin or telemetry converter, let's say, right?
And I love the fact that we're working with OPC UA Foundation and not just creating something completely on our own.
Exactly.
And I'm a huge fan of that, just because there's a lot of people, a lot of community members part of this standard. It's been around for a long time, and it's great that we have a part of it.
Right. So that's the new Microsoft, right?
Yes.
I mean, and actually supporting open standards is definitely the way of the future.
Yeah.
And I mean, yes, it takes a little longer, right? But I mean, you can develop the product as you're developing the standard, right? That's what we did.
Yeah.
So we were the first to actually support OPC UA PubSub with the publisher. And as when the standard was finally released, we already had the product available, right?
Yeah.
And similarly, we created what's called OPC Proxy. Now OPC Twin actually supersedes OPC Proxy. It kind of has the same functionality, plus is more performant. So OPC Twin does multiple things. There's an edge component and a cloud component to OPC Twin.
Yeah.
The cloud component gives you that REST interface that people want. to interact. I mean, people want REST interfaces when doing cloud development, so we have that REST interface now. And you can browse a machine, you can interact with a machine as if you are in front of it from the cloud. And of course, in a secure way, right? So we use service-assisted communication. The firewall stays closed, right?
Yeah.
So that is what the Twin does. And, you know, it also discovers machines that support OPC UA automatically. For the ones that don't, obviously we need that plugin, that adapter from a third party, from one of our partners. So how that works, I'll talk about in a minute. But fundamentally, we have the ability to automatically discover OPC servers because, believe it or not, a lot of folks can't remember what the IP address of their machines are because it was set up 20 years ago. You know, and
I've seen that before. Yeah.
So yeah, you gotta find it somehow,
that's
right?
Fair. Yeah.
Yeah. So that's what we decided. I mean, we need an automatic mechanism there, and of course, it also helps if people don't need to type in IP addresses manually, right? But a lot of network operators don't like scanning on their network. So we also support actually typing in the IP address, right? But obviously that requires the IP address to be well known. And then finally, we also can, in a secure way, execute methods on the machine, the ones that the machine exposes, and again, through the OPC Twin from the cloud. So, and we're the only ones who have that technology, right? So that's something that certainly for the digital feedback loop you need, right? And then finally, we've discovered that there's no good certificate management solution because obviously OPC UA uses certificates for authentication and so on. So we built one also based on the standard, on the OPC standard. We call it OPC Vault because it uses Azure Key Vault under the covers. And again, it's open source, available on GitHub. So that gives you, for the first time, a truly global certificate management solution for your OPC certificates.
And for folks who are familiar with Azure or Key Vault, is there any big difference between folks who've worked with Key Vault before and what we just released?
So there's a new REST interface. Okay. So OPC Vault wraps Key Vault.
Okay.
It uses Key Vault as a private certificate authority.
Okay, I see.
And we keep the private key obviously in Key Vault, and if you want hardware-backed storage, secure storage, so HSM modules basically.
Yeah.
So if you use OPC Vault in that way, it's just a configuration setting. Okay. The private key stays in special secure hardware. Obviously, it's never exposed, right? And you can send certificate signing requests to Key Vault through OPC Vault and get your signed certificate back, which you can then install on the machine.
Okay, makes sense. Yeah.
Yeah, so that's basically how that works. And then finally, I talked about the adapter modules already. We're working with all the major players that support, connectivity to industrial devices, and they're all obviously supporting connectivity to Azure, and we're also working with them to support that connectivity on our Edge platform. So very soon, we're going to have some Edge modules that have already been announced on the Edge marketplace from those players, such that installation can be done from the cloud, right? So you have to have your Edge obviously up and running. To make the Edge configuration and Edge setup as simple as possible, we built an installer such that it's like a single click task, and you don't have to sift through pages of documentation. Right? So that's obviously helps just to make that experience as seamless as possible and have that easy button experience where you click on the installer and it does the setup, and then once available, those modules can come down from the cloud. They're all containers, Docker containers. They can come down automatically. And then I mentioned already, there's obviously a lot of hardware vendors as well that obviously build industrial grade hardware, or you can just use a VM. In fact, most of the manufacturers that we work with have a little on-prem data center, and they can just spin up a VM too. That works.
Yeah, you can find any of those type of certified devices in our device catalog, and I love that you mentioned the partners, because anytime you're building an IoT solution, it's always it's a partner. It's always a partner ecosystem.
Yeah, it is.
There's not one person, all the way through who's just building something.
Well, and they're set up to do this properly, right?
Yep.
They've been in this business forever, right? So it totally makes sense for us to leverage and work with partners rather than trying to do this ourselves, right? It makes no sense. Yeah. So that's kind of what we do here. And then finally, this is kind of the overall architecture where we have obviously our edge components, the OPC Publisher, the OPC Twin, like I talked about, the OPC adapters for the machines. Obviously, we connect at the PLC level. We stay away from the sensor level. So there's usually a PLC or a gateway, a sensor gateway somewhere on the machine that we can connect to.
Yep.
We convert it to the OPC UA common data model, and then we make that data model also available in the cloud using CDM, the common data model. And then, obviously all our services that are available in our PaaS platform just plug into it and are available for you to use.
Easy peasy.
Easy peasy. Yeah, easy peasy. That's exactly right. What could go wrong, right? So then finally we have, because we started, developing these components, these modules, these containers, and people said, that's all great, job well done, but how does it all fit together, right?
Yes, you have all of these different services. That's a question we get a lot.
Exactly.
Yeah.
So we said, okay, well, we gotta show the starting point.
Yes.
We're not in the industrial solution business. We have partners like PTC who do that really well. So we said, okay, but we kind of need to show people the way, right? So we built a solution accelerator, right? That we call surprise, surprise, connected factory, right? And, we basically show people, okay, this is how it all fits. You can try this out using your own Azure subscription. We optimized on cost, right? So it's not this super scalable architecture that you want to go into production with, but it shows the way, right? Yeah. And then, we obviously also use all our security mechanisms that we put in place to really show, okay, this is how you would secure the telemetry path, the, connectivity to the cloud and all this. So this was important to us to really show. And actually building Connected Factory, we did find quite a few holes that we fixed, and we used an external company to do penetration testing. So we really feel confident that the security aspect has been addressed, right?
Yeah.
And we really wanted to show people this is how you do it, right? Because we get that all the time, right?
Yeah, and with Connected Factory Solution Accelerator, how's this one different between our remote monitoring and predictive maintenance?
Right, exactly. So that's a good question. Remote monitoring, predictive maintenance are kind of horizontal solutions that can apply to to almost any vertical. Connected Factory is specific to the industrial vertical. It's actually based on remote monitoring. So we took remote monitoring and extended it with our industrial components and built a dashboard. The most obvious one was to do an OEE calculation, for equipment efficiency, and you can see that in the bottom here. I'll do a demo in a minute. But fundamentally, doing simple dashboarding is kind of the step 3 in my 7-step process. So we said, okay, we'll take it as far as that.
One question I get a lot is your solution accelerators, how's that different from IoT Central? And the one thing I try to explain to them is that IoT Central, we're managing those services for folks. And for these solution accelerators, is what you were highlighting before, it's really like this reference architecture of these past services coming together to show an example of a particular scenario.
Exactly.
For this one particularly, Connected Factory. So if you're trying to think of what's really the differences between the two, that's really what it is managed services versus the services you're still managing yourself with the solution accelerators, but we help you deploy all of them for
exactly.
you.
So the main focus again for Connected Factory was not to build a SaaS offering, but just to show people how they get started building their own dashboard. How the PaaS components fit together, how our industrial IoT components fit into it, and then do some basic alarming and eventing, stuff like that. And of course, it's all open source, right? So you can just download the code and start, modifying it to your heart's content. Right?
Yeah, and I remember when we first released this, there's definitely some changes of Connected Factory when we released and now, because we have IoT Edge support now. What are some other differences between when we released a long time ago the Connected Factory, so people who played around with it at that time versus now?
Well, the biggest change that we made is the integration of the OPC Twin. So obviously that didn't exist when we released Connected Factory. I mean, yeah, we changed the colors, right? Yeah. That's also important, right? But to get that consistency with other solutions. But really the biggest change that we've made over the year is the integration of the OPC Twin, to have that simple one-click experience for setting up the edge, right? Edge support, obviously. So I can do a little demo now.
Yeah, that'd be great.
Let me just change this over.
This is always the fun part of the deep dive.
So here is the Connected Factory, and if I could just go back to the homepage. So fundamentally, the homepage hasn't really changed much from the beginning, apart from the color scheme. We did integrate the Azure map service here. This is now Azure Maps. OEE calculations down the bottom as usual. So this page is pretty much the same, but it gets different here, where now we have edge integration. So these are all edge, IoT Edge gateways. Some of them come from actually all of them in this case are from our simulation, right? So we have a simulation built into Connected Factory, so we can actually show something, right? Otherwise all the dials will show 0. That's kind of boring, right? So we added a little simulation of 7 different production lines building virtual products, right? That gives us OEE and so on. So that's basically what we've done. And this is the scanning functionality for OPC servers that I showed, or I talked about. And basically when you connect your own gateway, it just shows up here, right? And then you can hit the scan button, and then eventually you'll see some endpoints here, and those are the actual OPC servers, right? So then an OPC server can have multiple different endpoints, like so you'll see the same OPC server with different endpoints here. And then
sorry to interrupt you, but do we have a limit of the amount of endpoints you can have with the servers?
No, there's no limit. Most have 5 or 6, right? So that's kind of standard. Some only have 1, right? It really depends on the machine builder to make that choice. So then, obviously, the OPC Twin also supports browse, just like before. But now you can see it's a lot faster than what it used to be with the OPC proxy, because we've made quite a lot of improvements to the performance. And you can browse the OPC UA server namespace, or basically the data model, right? And then you can also, like before, browse in here and then see the telemetry that's already getting published. And if you want to publish more telemetry, you just click on it, hit publish, and then that's it. Now you have a little checkbox here, and data starts streaming automatically using the OPC Publisher to the cloud. That's it. That's the only thing you need to do. And then if you look at Time Series Insights Explorer, which is still integrated, you'll start seeing this additional telemetry show up in the stream. And then, do you have a question?
Oh, I was actually going to ask, once you're done with done with the demo, was customization. If people want to start playing around with Connected Factory, but they really want to connect their own devices and just start somewhere after they've played with Connected Factory.
Exactly,
what would you recommend?
Well, that was the thing I was going to get to next. So if you hit this button here, yeah, totally. So if you hit this button, it gives you instructions on what to do to connect your own production line, right? So
I just needed to wait 5 seconds.
Well, there you go. You were a little ahead of me. But anyway, so we've actually, because people say, well, what gateway should I buy, right? I mean, that's a fair question, right? So we said, okay, well, here is a pre-filtered list of our device catalog. You click on that, and actually, that's not the right link. Let me just find it here.
But if you want to see supported Edge, you go to that link.
Exactly. So this is basically what Edge supports, and let's see. This is the installer. So we also have a link to the device catalog. I can't find it right now, but it's there, right? And then finally, you can click the installer here immediately. So you run this page from the Edge. Once you buy your Edge device or set up your VM, you browse to this page, you click on it, and it immediately launches the installer to install the Edge runtime and all the components that you need for the industrial scenarios. And then all you need to do is go back here to the other tab, and your edge device to this tab. And then your edge device will show up, right? And then you can start browsing endpoints and start selecting telemetry, and that's it.
I love this. It's a great starting point, and to get the idea of what's possible with the different services. You mentioned a little bit about scalability when you first talked about the connected factory. For folks who are thinking about scalability, what are some factors that they need to think about? They won't be using the connected factory for scalability, but what are some best practices when they're looking at the end-to-end solution?
Right. So for cost reasons, we basically deployed both the dashboard and the microservices like the OPC Twin and the OPC Vault in application host. And obviously you wouldn't do that in a scalable environment. You use things like Azure Kubernetes services, right? That would be a change. And then also, obviously we use the most basic IoT hub SKU that you can afford. And then, as you're scaling to hooking up multiple production lines, you would use a higher SKU of IoT hub, and similar for time series insights, the same. So again, it's more about growing your architecture as you start adding more devices, adding more factory lines in this case. Again, to keep the costs down, we really wanted people to be able to look at connected factory using the free Azure account, where you have $250 a month credit, and that's why we try to squeeze everything into that $250 limit. And this is why some of the scalability topics haven't been addressed, but that was on purpose, right? To keep the cost down, right?
Yeah, so more people could get the idea of how to build the solution and have a starting point.
Exactly.
Yeah. It makes perfect sense.
One of those classic trade-offs.
Yeah.
Right?
Good trade-off, though.
Exactly.
Yeah.
So then we have some resources, obviously, there. Here is all the source code for our components. Again, everything's on GitHub, including instructions of what they do and how to deploy them. We have pre-built containers in a container registry. So as you're deploying Edge, you don't need to build anything. You just, the installer does that automatically, but you can also use Docker to just pull down the images or the Azure portal, right, to create your deployment script. That's all done for you.
The beauty of containers.
Beauty of containers. There's also some high-level instructions on Microsoft Docs. What's Industrial IoT and, why is it important, et cetera, gives an overview of the components, what they do. Then, of course, we have the connected factory source code. Like I mentioned, it's all there. It's also on GitHub. And then finally, we have some resources which, allow you to browse some of the past services that we obviously also use, like IoT Hub and TSI and so on.
Exactly. And I love that you have pulled up the IoT tech community because after this deep dive, if you're interested in learning more and all of the links that we showed you, all of that information, I'll make sure to post on IoT tech community. It's a great way to ask questions. I'm on there. If there's any questions, we'll make sure that we ping it to you as well. But it's a great way to talk to engineering and also to other people in the community who are also building solutions. So if you have questions, or if you have blog posts or things that you want to share, some learnings that you've had, maybe you've built this really great IoT solution and you want to share and some of the best practices that you've noticed yourself, feel free to go ahead and just post on there. It's free. We won't tie you into anything. We won't sell your information to anyone. But it's just a great way to get that direct communication back and forth. And then also, if you have ideas for future deep dives, this is where you post, or you can tweet at me at altaohms. Before we close, I'm very interested in, is there any other top questions that you get a lot from customers and partners you're working with, developers who are building with industrial IoT that we didn't cover today?
Well, one of the questions I get sometimes is, can I use all of this even if I don't have OPC UA in my machines yet? And of course you can. I mean, that's the whole point. You need to, get to a common data model somehow. That's why we use OPC UA, right? And because of the security aspects. But of course, you can connect every machine that I've come across using our partners' adapters, this is not a requirement, right? So, and of course the adapters are available in different SKUs as well. So depending on what size production line you have, you're not going to break the bank just buying an adapter. But fundamentally, it's the best architecture that we came up with is to use those existing adapters and those existing industry leaders to come to our platform, support Edge, support the Azure cloud, and connect things just like you did in the old days when you created your SCADA dashboard or your MES system. It's exactly the same, right? It stays the same. The only difference is now we have Edge involved, and of course the cloud, and possibly even Azure Stack, right? So
that's a question I get a lot.
Right. So I mean, there's nothing stopping you from creating an additional layer, right? So you have machine, Edge, Stack, public cloud, and not Edge, public cloud, right? So you can run most of the services that we have on Azure on Azure Stack, and of course we're adding new services all the time, and we get that all the time actually, that we create this solution to run either on Stack or the public cloud, and the customer can choose, or even run a hybrid scenario where depending on the workload they choose one or the other.
Well, great. Well, I'm excited that you joined us.
Well, thank you. Thank you for having me.
Yeah, thank you. Thank you for being here, and thank you for joining. We'll have this on demand, and we'll continue to answer your questions and chat. So thank you again. And we continue to have these bi-weekly. So if you have any suggestions, feel free to ping us on Tech Community. So thank you.
Well, thank you.
Right.
Cheers.
Bye.
Bye.